Hello, my name is Mickey Ballenhofer. Here's the paper. It is March 16th, 2026. So today I'll be presenting albuterol, which is and talking about its chirality, structure, and medical use. So the albuterol, also known as salbutamol, has the molecular formula of C13H21NO3. And its IUPAC name basically describes a phenyl ring with hydroxyl groups and a tert-butyl aminoethanol side chain. It's kind of a tongue twister there. Um, so what is albuterol? It is basically like a medication that is used for asthma and COPD in order to help like the lungs breathe and open up. So it works by relaxing the smooth muscle, the bronchial smooth muscle, and it helps restore airflow during bronchoconstriction. Because the drug is chiral, it's two mirror image forms. They don't really behave identically in the body, and it's basically delivered by inhalation, of course, through the nose, and giving rapid onset with fewer systemic effects. So functional groups, there's several, but I'll give you the four here. So, first one would be the phenolic hydroxyl groups, which increase the polarity, being able to enable hydrogen bonding within the receptor. And the secondary alcohol increase the polarity and enable hydrogen bonding within the receptor. The secondary amine is becomes absorbed within the body, which basically is important for receptor binding. And the aromatic ring provides provides like and helps support hydrophobic interactions within the receptor pocket. And then these next two slides are basically describing the functional groups here that I talked about. And then here's what it looks like. So chiral centers. So albuterol only has one chiral center, and it's on the ethanol side chain. So in order to classify R or S, we have to use the CIP rules, which basically help rank the substituents based on the atomic number. And how the CIP basically works is it goes first, it goes by highest priority, which is the hydroxyl group, because of course oxygen is the greatest atomic number among the atoms that are attached here. And the second priority goes to the phenyl ring, because that carbon is directly bonded to other carbons. So, and then the third one is the methylamine side, which is that bottom one here. And it's where the carbon is attached to nitrogen. So that's third priority. And then the last priority one would be the hydrogen, which is oriented away from the viewer uh, in the correct orientation. As you can see, the black wedge there. Oh, sorry, I mean in this next slide. It's the not the black wedge, it's the dash line. That's the back one. But everything I described is on this slide where it has all the important information with the numbers, as you can see. One, two, three, and four. Now the chiral center identification configuration. Um, the R enantiomer of the albuterol provides superior bronchial dilation, while S enantiomer may have minimal or harmful effects. The stereochemistry influences metabolism and receptor binding and drug action duration, affecting clinical outcomes. So, isomer categories and importance. Albuterol has two enantiomers, but no diastereomers because it only has one stereocenter. Understanding isomerism is really important, which is why we have levobuterol, which contains only R enantiomer. So the medical use and so albuterol works by activating the beta 2 adrenergic receptors. I can't say that word for some reason. Adrenergic receptors, which basically increases the cyclic AMP and relaxes smooth muscles in the airways, basically allowing it to open up for the person who has asthma or GOPD, being able to like breathe in better. And this widens the bronchi and provides rapid relief during asthma symptoms. And because the R enantiomer is more effective than the S form, stereochemistry directly affects the drug's clinical performance. And that is my presentation. Thank you very much.